Okay, so this is a quadratic. Let's see. We've got a quadratic shifted to the left 4, down 4, and then it's got a vertical stretch by a factor of 2 because it's on the exterior, right? Sorry, that's kind of small. So what's interesting though is that it's restricted to less than or equal to -4, which is where this vertex is. So imagine we've got a quadratic shifted to the left 4 and down 4. Opens up, the vertical stretch just makes it steeper. But then we're restricting it to x is less than or equal to -4, so we're restricting it to this side. Yeah? So I'm actually only going to see the left side of it, not the right side of it. Okay, so as far as sketching it goes, I'm going to go ahead and go left 4, down 4. Left 4, down 4. And I'm going to apply the pattern to a quadratic, so only the left-hand side. 1 squared is 1, 2 squared is 4, 3 squared is 9. We've got a vertical stretch by a factor of 2. So that means going up 1, we're going to go up 2, we're going to go up 8, and I'm not going to be able to see 18, so I don't have to worry about that one. So I'm going to go left 1 and up 2, and I'm going to go left 2 and up 8. So from -4, I'll be at +4. Okay, so please don't draw it just like straight up, like it's a line, because this is half of a quadratic, so it should leave it as if you're planning on being able to turn back around right here, right? So that point, arrow. Okay. So then my domain is going to be from -infinity. Just try to do it again. -infinity until -4, because of that right there. And then my range is low to high. The lowest it goes is -4, and it goes up to infinity. So that's for f. So now my inverse, the domain and the range are going to be the flip of that, 4 to infinity, and the range is -infinity to -4. So remember, the range of your inverse is the revealing part as far as like which square root you're dealing with. So if we find the inverse, so x equals 2y plus 4 quantity squared minus 4. Then we're going to add the 4 over. And then we're going to divide by 2. Dividing by 2 is seeing these multiplied by 1/2, so that's what I'm going to write. 1/2 x plus 4. Now, you could right here distribute your 1/2. The only reason why I'm not going to right at this stage is because it helps me see my transformations. So if you can leave those outside, then you're a little bit better off. We're going to take the square root, and when I take the square root, I'm going to remember there's two answers, plus and minus. So plus or minus the square root of 1/2 x plus 4 quantity, well, all to the square root. Doesn't really make much sense. And then the last step I'm going to do is subtract the 4. So I've got the square root of 1/2 x plus 4, and then minus 4, and that equals f inverse. And the question is it plus or is it minus? So I've got a square root, right? You've got a square root shifted to the left 4 and down 4. And so the question is it going to be this one or is it going to be this one? Keeping in mind that my range should be, for my inverse, -infinity up to -4. So that means it should be this part, which is the negative square root. Or you can just remember if it's the left side of the quadratic, then it's the left side of the quadratic, then it's the negative square root, and if it's the right side of the quadratic, then it's the positive square root. Like we decided on that one. Okay. So I'm going to go ahead and flip the points and sketch them. Actually, I'm going to go ahead and state my transformations first. So this is interesting because this is one case where it looks like I have an extra transformation because of that flip. But that's because we had this extra restriction on the original where it was only the left-hand side. So it's the square root function flipped over the x-axis, horizontal stretch by a factor of 2, left 4, and down 4. But we'll go ahead and just flip these points. It's -4, -4, so -4, -4. This is -5, -2, so -2, -5. This is -6, 4, so 4, -6. And I'm going to keep in mind that this has that shape right here where it comes off like this, as if you're going to turn around right there, okay? And so there we go. There's my inverse, and they're reflections of each other across the diagonal. Yeah. I don't know if I got off the diagonal anywhere. Yeah, I did. Okay. So there we go.